Hey YouTube, JP Dillon. So people kind of voted in the last video about checking out the old Chromacolor Zenith. That's what we're going to look at today. We already know it runs, so we're just going to kind of open it up, check out the insides, and then do the setup adjustments on it. You can kind of get a feel for how well these things are made and what a good picture they produce when everything's working. But the first thing to do, obviously, is to get it apart. So we're going to take it apart. I'll show you the wonderful build quality on this thing. And this is really a set that represents why Zenith was famous for the quality goes in before the name goes on. But we'll show you that in just a moment. We're in the shit shop today, so it is a little bit messy, and things are just kind of discombobulated due to all the stuff I have to repair in here in the limited space. So I apologize in advance for the messiness. But anyway, let's take the back off, let's get cracking on it, and you can see what's inside. So here it is with the back off. As you can see, it's the infamous 4-tube hybrid. You've got your combination your horizontal oscillator and drive, your vertical output, your dampener, and your horizontal output. And then you've got the flyback and tripler assembly back here. Very rarely do those triplers fail, but they do die. This one still has very good high voltage. This is typical of something you're going to see from 44 years ago. Moderate amounts of dust. And so let's just really quickly dust this off, and then we can go over the chassis. Alright, so here she is a little bit cleaned up. And pretty much everything except the sweep is transistorized. So you've got your transistor UHF and VHF tuner. There's your IF strip. This is your video amplifier stage here. This is your chroma and burst amp. And inside the shield is the color oscillator, your 3.58 megahertz chip. And then here are your video drivers, your red, green, and blue, and taps to adjust the output of the red and blue. You've got your soundboard, which is the stand-up one here. There are a couple of video detector transistors, and I think this here, the big fat ones, are your sound output, although you can, if it's still available, look on the diagram on the back, and it will usually tell you what it is. A third video amp, video blanker, vertical oscillator is a transistor, but the output tube is, well, still tube, obviously. Tells you what the bell fuse leads are, coloring of the leads. Another thing you notice in this, this is all point-to-point up to the modules, which is cool. And they've got a lot of service adjustments on it. Most notably is that the Convergence is completely adjustable on a delta gun. You've got your static adjustments here. This is your blue vertical, your green, and your red, and your blue lateral. And then you've got your dynamic adjustments, which are clearly labeled here. Make sure to use non-metallic tools on these cores or you'll break them. Then on the back, we see all the service adjustments. You've got your color killer, your peak picks, also known as your sharpness. You've got a couple that are blocked off too. I don't think there are actual pots in here. This would be a AGC carrier level, brightness limiter, volume limiter. The drives on this one are fixed with the jumpers. Otherwise you'd see those be open there. Your vertical linearity, your service switch, which does get touchy, your screens, your vertical size, horizontal hold, horizontal centering, vertical centering, your pin cushion adjustment. It does have a vertical pin cushion adjustment for it. There's your high voltage adjustment, which denotes 25 kilovolts. And your horizontal phase control. I don't remember if the phasing control affects the drive or not, but that's for somebody with a little more expertise on that subject matter. Your filter is behind the tripler there. The entire chassis is capable of unplugging in various locations, and it is marked. although I still make a diagram. Here's your red degauss leads, your speaker leads. Pretty much everything you need to service this is a completely modular set. And we'll put it up on its side, and you can see underneath how everything's beautifully hand point-to-point wired. So here's the chassis up on its side, and they do have a snap-out panel. If you remove this nut, the rest of this comes off for complete access to the chassis in case you don't want to remove it. But everything is wired point-to-point to the modules. It's done very nicely. Everything's just so wonderfully put together on these. And they use a lot of film and ceramic caps, which very rarely die. You might see one of these with a bad electrolytic, but otherwise they don't really have a need for heavy recapping and replacement. They're pretty bulletproof. If you ever have to replace one of those screen pots, make sure to do it with the same type that's insulated. Otherwise you could have a couple hundred volts on the chassis that could arc over through the potentiometer, which is not good. I believe here is your vertical output transformer. There's a 24 volt regulator here, which is for your solid state. There's another test switch for the color up here, which you can get to from the top of the chassis, I believe. Someone's done a repair on this at some point. You can see the new rectifier that was put in somewhat haphazardly, although they may have just done this for a test purpose. I certainly wouldn't have left them hanging out there. Maybe I'll clean that up. There's your degaussing thermistor there, which also looks to have been replaced. I'm not sure if this is a choke or an audio output transformer. I really don't remember. It's been a long time since I've been inside one of these, probably a good 15 years or so. Common with zeniths of the 60s, the brightness, contrast, and vertical are still on the side. They don't have a lot of front controls other than the basic color and brightness and volume. In fact, this one is just color and tint and volume, and then you've got your chromatic, which is your preset color, and your AFC and your on and off. And this does have the original Roland made Chromacolor CRT, the 19VCQP22. Black matrix, nice bright phosphors. Trying to look for an EIA number. I guess it's kind of covered up there. So, that's kind of a rundown of how well these things are made. Next, what we'll do is get a signal source hooked up, and I think we'll make an attempt to clean the pots and stuff on the back, and then we'll do the setup adjustments, check the high voltage and all that, and make sure it's happy, and then we'll have some fun with it. Alright, so we've cleaned all the pots, and now we're going to do the basic setup adjustments. And what you're going to want on an older set like this is a couple things. Number one, you're going to need a cheater cord to run it with the back off. That's most important thing, number one. Number two, you're going to want a test pattern generator of some kind. Until I got this, my WR64B RCA generator was my go-to. That's pretty handy. The third thing is for these old tube sets, you're going to want a high voltage probe. Don't skimp on this stuff. Open your wallet, buy a nice high voltage probe. It doesn't have to be lots and lots of money, it just has to work. This one I bought, that happens to go with my fluke meter. It was really inexpensive because I bought it used and made sure it was calibrated, and I used that. And then if you want to get even more technical, you could take the cathode out of circuit and put your meter in series with the cathode to ground for the horizontal out to measure the current. Although I don't believe it's adjustable on this one, I may be incorrect. So, these videos that I make, I probably should have said this years ago, but these videos I make are assuming that you have some sort of technical experience. Within these old television chassis are anywhere from 400 to 600 volts to 30,000 volts. So, use caution. If you're using a line-operated set, buy an isolation transformer. It's the best $60 that could save your life. So anyway, let's begin. Let's flip the switch and we'll wait for it to warm up.
City Medical Center. Advanced health.
So you always hear audio before you do video on these, since obviously the audio portion is solid state. I'm just using a DTV box, so it's probably going to be choppy because I'm in a crummy signal area. I hear a high voltage. Crackle, crackle. No picture yet.
Off stage, I'm going to ask you 5 questions in 20 seconds. If you can't think of something, you just say pass. You and Freddie together come up with...
Alright. Okay. Now obviously, since I've been messing with the pots and things, we're having a crummier picture than you saw the first time I turned this on, which still was retaining basic setup adjustments. So the first thing you want to do on this is give it a little bit to warm up, and then you want to check your high voltage, and you want to make sure that the high voltage is on the specified value that they want. In this case, they want 25 kilovolts, and that's with the service switch in the service position. So what let's do is let's flip it around, and I'll show you how to hook up your high voltage probe so you can safely test this. Alright, so after you've given your set about 10 minutes to warm up, what you want to do is go ahead and flip your service switch to service. If you want to, you can even turn down your screens if you've got a line on the screen already. We'll just do that as a precaution. And then what we're going to do is on your high voltage probe, if yours connects to a meter, do so in the intended manner. If yours has a built-in meter, you don't need to do that. And then the high voltage lead will, or the probe will have a ground lead, which you have to clip to wherever the manufacturer says to do it. In this case, they want you to clip it to chassis ground. So we're just going to find an open spot here on the chassis, just like that. And then I'm going to turn my meter on, and I'm going to take my high voltage probe, and you're going to want to slip it underneath that cap up there. Let's get some light on it, just like that. And you're going to hear some hissing and stuff as it attracts the high voltage. So, we're reading 24.6, which is pretty damn close to what it's supposed to be. So, and it's stable, it's not bobbling. If you want, you can top that out at 25K. I'll do that, but I need 2 hands to do that. So let me go ahead and tweak that out, and then we'll go on to the next step. Alright, there's our straight up 25K. So on to the next step. Okay, now that our high voltage is set, the next thing we want to do is do our grayscale adjustments. Now the drives on this are on a fixed value, so we probably won't need to mess with those. So we will do the screen setup adjustments. Since the machine is already in the service mode, what you want to do, and this is going to be a little bit tricky here because I have to hold the camera and balance it at the same time, we're going to adjust our screen voltages to where we just see a line on the screen, indicating that the proper bias is set on each gun. So I'm going to turn up the red, and there's our red line, and you just want to be able to see it, just barely. Okay, now I'm going to turn up the blue until our red line turns magenta. Yeah, that was not cooperating. What about our green gun? Does the green one cooperate? Oh yeah, the green one's really strong. Alright, so we have a problem, and the problem is we're not getting enough blue. Yeah, the blue gun isn't turning up enough. So let's turn our service switch off briefly. And let's see if we have blue drive at all. Yeah, we do. It's just not very much. It kind of gets close, but not close enough. Alright, so let's see if we have a bias control that allows us to crank up the screen voltage on the blue. Alright, so just out of curiosity, I got out the Beltron CRT tester, and all three guns are pretty much excellent. So, and the fall off rate, if we hit the interrupt switch, is good. Wow, going on 10 seconds. Long time. Alright, so something else is going on. So the next thing we have to do is check voltages to the screens and see that everything is getting equal voltage, and maybe up the voltage a little bit for the blue, because I'm betting it's lacking. So that'll be the next thing we mess with. Alright, so the CRT tester nominally says that it's all good on three guns, yet we don't have blue, or we don't have enough blue. So let's take some voltage measurements and compare our supply voltage to what it is coming out of the screen control. So coming to the red, 800 volts on one side, 294 on the other. That's with it all the way down. And if we turn it up to where we see red on the screen, the center terminal, 630 volts. So the red's good there. If we go to the green, we've got 824 on the high side, 294 on the low side. If we turn it up to where we get green on the screen, we get 554, so the green's a little bit stronger. Yeah, let's come up here to the blue, if I can get to the blue. Let's see, 822 on the high, 294 on the low. If I turn the blue all the way up, I get 822. That's interesting. So wow. So 822 going up that center pot there. It's interesting. Let's compare with our green again.
And then to the game building. It's really a spectacular environment to entertain.
If I come up to the green wants about
The kitchen is
550.
amazing state-of-the-art kitchen. Got the Melee coffee machine, Sub-Zero
292.
appliances.
Yeah, if I go all the way up here,
Everything is just really top of the line. Great
crank it all the way up to 818, we still got no blue on the screen.
right off the kitchen.
So either the voltage ain't getting to the socket well enough,
Kind of patio,
or we've really got a bad blue gun.
and it's just got a great feeling. And you can
So, I guess we got to trace that out a little bit. Alright, so the next thing we're going to do is we're going to try to take this socket apart, and I'm going to see if the pin for the blue screen is good, and I'm going to see if the wiring to and from the screen control is good, because it seems like there's just not enough current draw. The fact that I can crank the screen voltage all the way up to 800 and I'm not seeing anything, either it's not getting there or this is really a bad CRT. So that's the next thing we got to find out. So I'm going to put the camera down and take this apart, and then we'll see what we find regarding that. Alright, I'm starting to worry a little bit here because I tested the resistance between the blue screen pin and the output of the blue screen control, and it ohms out okay. These pins don't look bad. There's no oxidation on them, so I'm beginning to think that the CRT might actually be bad. So I have several CRT testers. I usually just use the Beltron as a basic functionality test. I have a Superior Instruments company, an old B&K, and a couple of Sencors, but this one so far has been my favorite. This is a CR168, and it seems to give the most truthful condition of the CRT. So I'm beginning to suspect that this blue gun is just toast. And although the Beltron does test for cathode emission primarily, this also tests things like cathode emission, shorts, gas leakage, cutoff, and the like. So we're really going to see what this one's capable of. And it might be that this CRT is just bad, which would be unfortunate. But so what this is, if we zoom in here, this is a 19 VCQP22. And so somewhere in here I have my little booklet. And we'll get a 19 VB. VCAP. VCQP22. So it's bias setting D in socket 9. So we'll make sure that's on bias setting D. And we'll go ahead and use socket 9. And let me assemble this and hook it up since it really requires two hands. Okay, well, she's all hooked up. Let's see what's going on here. Go ahead and set our filament voltage. And we'll bring it up to about 6 volts. Not quite 6.3. Check for shorts. Red, green, and blue all look good. Grid 1 short. Red, green, and blue all look good. And now we do the gun balance test. And what you want to do is adjust each one until it comes up to this mark here on the meter. So here's the red. And I don't know, that one's not coming up at all. Let's go to green. It comes up a little bit. Blue comes up nothing at all. So let's go back to our filament. Filament's in the right spot. We've got our bias set at the right place, but none of these are really adjusting at all. They should be doing something, but they're not. The green moves the tiniest little bit. So that already tells me that the CRT really is very likely kind of weak. So let's go to emission. It says the emission on the red is good. Green is good. Blue, not so great. So that may explain why we're not doing so good. Let's go to tracking. And it says the red has bad tracking. And I think that has something to do with the gun balance. But then again, if I go back to the gun balance, that doesn't do really anything, so strange. Let's just take a quick look and see what the gun balance setting is supposed to do, since it isn't behaving at all for me. Yeah, I seem to have misplaced my owner's manual, although I do have my cool little warranty card. Well, anyway, I don't think this is behaving correctly, because I should be seeing some sort of register on the gun balance thing, but I'm not. And definitely we turn them all up. See how that changes? Of course, this is all, you can't really tell. There's something going on with this one because I haven't had this problem before. Maybe something happened to this. It doesn't, it does change with bias setting. And it said it was supposed to be debalance, or debias. But see here, I can get these all to balance out. Likewise, if I go to C, nothing on C. I can go to C. And blue doesn't do shit. So, all going back to this, with this bias setting, these are all wonky. It's weird. Yet if I go to this bias setting, or B bias setting, I can get all these to balance. Maybe it's the wrong bias setting. Maybe they made a misprint. Of course, now it says it's all good, so ugh. Let's double check and make sure I know how to read. VCQP 22. Yeah. D-bias and socket 9, which is what I'm using. So it definitely doesn't behave as it should. And if I adjust these, they're all funky. Let's look further into this. Alright, I got the service manual setup book, so I have now found out how to set this correctly. Stupidly, I was trying to balance it with the bias already set. You're supposed to balance it before you set the bias. So leave bias on A to balance it, then set the bias, then check emission. Alright, so we've got our filament. We're doing our HK short tests, which are good, or D1 short tests, which are good. Our gun balance, see, now I can adjust it. Yeah, let's balance all these out. Alright, and then we'll go to emission. Blue looks good. Green's a little worse than blue. Red's about the same as green. And if we go to tracking, tracking looks good because there's no deflection. So again, the tester says this is pretty good. Frustrating. Yeah, I don't know what's going on here. Trying to think of what else could be causing the blue to be out. Because I've got two testers now that say it's good. And I jiggle the socket. Ain't nothing change on it unless I remove it. So yeah, it's different. Alright, more troubleshooting. Alright, so it looks like all signs are pointing to a bad blue gun in the CRT. I tried moving the screen wires around, soldering the blue to the red pot, and etc. And you can put full boost on it, which is 800 volts, and the blue just never quite comes up. So what we're going to do is adjust it without the service switch. And what you want to do is set your brightness or your contrast to a minimum, and then you want to set your brightness to where you can kind of you want to set it to about maybe 3/4 of the way. And then what we're going to do is turn down our red and blue, and we're going to turn up our brightness limiter control until we can kind of get a blue. May or may not work. Let's see. Alright, so that's as good as we get with the blue. Kind of makes me sad. I'll have to find another CRT for this thing. And then we'll adjust the red so that the blues start to look magenta, and the green so that the rest of it looks acceptable. That looks pretty black and white. Alright. Now it's starting to look like a black and white picture. That's acceptable brightness. It's about as bright as it gets. I wish it got brighter. But that still doesn't mean we can't have some fun with it. There's our color. Let's turn our AFC off and adjust this. Turn AFC on. It's looking better already. Alright, so that's all set up at least. Okay, so you got your grayscale. We know the color works. Now the next thing we can do is the setup adjustments. And you'll want to do this before you do the convergence. So let's see where my vertical size is. Excuse me here. Centering. Size is back here. And what I'm going to do is adjust the vertical size. Ooh, that's a touchy pot. Until I start to see the retrace. And then go crease it till it goes away. Alright. That's a little better. This is really disappointing because I was hoping to get that hoping to get one of these with a good CRT. I mean, it produces a good picture, it's just not kicking that blue up enough for whatever reason. Don't know why it's not. I wonder if there's something bad with the control, but then I tried moving the wires around and using supplies from different controls, and it's just not there. Yet it's still sharp. It's kind of depressing. Alright, well, what I can do is we can work on the convergence and stuff like that next. I really should have set purity, but it might change as I rotate the thing, so we may have to deal with that in a little bit. Seeing if I go back to the service position, it's just dark. There's no lines. Sad TV. I was hoping to do a full demonstration on this, but I really didn't know that blue gun was that bad. Well, interestingly enough, when I come over here to the cathode circuit, you've got a supply voltage 265 on all sides of these. On the green, we've got 265 on one side and 168 on the other. On the red, we've got 265 on one side and 167 on the other. And here we got 265 and 174, which is interesting. It's not too much of a difference, but in the cathode circuit it might make a difference. And likewise, there's our 170. We've got 17 here, 16.8, and 17 here. So this up here in our drive, these transistors appear to all be okay. So the video drive output seems to be okay, but for some reason the blue just isn't drawing the same amount of current. Because if it was, we would obviously see that there would be a lesser voltage here like these other ones. These both measure about 167.5 and 167.9, so they're pretty close. This is slightly higher, so it's pulling less current through here. But I guess if the blue gun's bad, then that would definitely present that problem, wouldn't it? So, goodness. I suppose I can go over and check all of these components here and see what's up. But I guess I'm just having a hard time wrapping my head around this one, because CRT testers say that it's good. But obviously it's not performing correctly. So it's just something we have to look at. Interesting enough, isn't it? Alright, ladies and gentlemen, here it is. There's our blue line.
Something like this happened to you. Do you suffer with pain?
It was in fact the CRT.
Do you have a chronic knee pain, back pain, or other type of pain? Well, if you have Medicare or even private insurance, there's good news.
It was in fact the CRT. Because if I
Call us right now to see how you can get a pain-relieving brace at
I took a chance and I
made a decision that makes
hit the tube with a rejuve,
you able to get out and enjoy life again. If it hurts
and it magically came back. So
to recline, make the call.
that's pretty much a dead giveaway
A pain-relieving brace can
that the CRT was at fault, because now, as you can see, I've got plenty of brightness.
7 Health Alert hotline now. Call 800-957-6062.
So let's do our red, green, and blue.
800-957-6062.
And I can see definitely that the guns aren't lined up. See how the lines overlap each other a little bit? I don't know if you can, because the camera's not really focusing. Let me adjust the blue static magnet. Alright, so we're going to start off again. We're going to do red till it's just visible. We're going to do blue till it's just visible, which would make magenta. And we'll do green, just visible, which would make it gray. And now, when I shift back to normal, I got a really bright picture with all nice grayscale. So that just goes to show you, you can't always trust what the CRT tester says. It might have said that the guns were good, but it wasn't. And now they all center. With this black and white picture, if we come to the output of the screen controls, the red is at about 600, the green 540, and the blue 560. So the CRT just needed a wake-up call. God, what a pain. Alright, so now that that's all out of the way, now we can work forward in getting the set converged and the purity done and all that. That's where the real fun begins. We've just been spinning our wheels looking for a bad component when in fact it was a funky CRT. So can't always trust the tester. Anyway, onward and upward. Alright, so now what we're going to do is do the purity and setup adjustments, which is going to require that we back off on the green and blue gun again. And if I go back here, excuse me just a moment while I turn those off. And I'm going to turn the red up so we can see it. Oh, there we go. And as we can see, the purity is kind of sucky. We've got a kind of a slice through here and some green here, and we also got a bit of a horizontal phasing problem. It's interesting. Anyway, what you want to try to do is you want to get the center, well, you want to get the whole thing as pure as possible, hence purity controls. And back here on the neck, there are these sliding ring things. I don't know if you can see them. Those things there. You got to spread them apart or push them together and rotate them until you can get as uniform a red field here as possible. And you can see as I adjust it, look at that. So tweaking with that, now we've got a red field. Isn't that nice? Much better. That was easy. Most of the time you got to play with that. That was just me spreading them apart. If we rotate them, you can also see that that changes the field intensity and all that sort of thing. But your idea is just to get a pure red field. And you may actually have to move it back and forth. I know the camera looks like it right up in here, the purity is purple, but it's actually a color balance thing. As you can see, as I put my hand in front of it, it messes with it. So that's that. Let's turn this down and then go back to service mode and do our setup again. We got red, we got blue, we got green, which goes back to grayscale mode again. Alright, now let's go on to static convergence. And we can see, or maybe you can't see because of the focus in the camera, but the blue is not quite right, and the red and green isn't quite right either. In fact, if we go to a dot, that's a little harder to see, but it's not really correct. In fact, if I zoom in on it, you can see the red, green, and blue dots not overlaying very well. Now, the red and green moves on axis this way, and the blue moves on axis this way. So you want to converge red on green before you do blue on the rest. Oh, it's just so close. Let's tweak the red a little bit. And do keep in mind you're working around high voltages, so beware. Don't do anything silly. Alright, so we got the red and green converged. Let's move the blue. And yes, it's all interactive, so it will have some effect on what you do. Okay, now let's switch to a standard crosshatch. Looks pretty good. Let's back up a little bit here. And let's do to a dynamic crosshatch. And not bad. Looking good. We got a little bit of deficiency here at this little corner, but I doubt that I'm going to be able to clean that up, considering that the sides and the top and bottom are all really good looking. The left's really good too. Now if you need to tweak this, that's what these things are for. These are your dynamic convergence adjustments, clearly labeled left side, right side, top, and bottom. And you can kind of dial it in. And they're all interactive, and it's going to be a pain in your butt because you're going to have to keep going over and over and over again. So I got lucky with this. I don't really have to mess with that. So yeah, let's go back to our color bars. Ooh, pretty. I'm liking the way that looks. That looks really clean. I really got to clean the pot on this generator. Let's do a rainbow. Not bad at all. I think this thing's ready to rock. Let's see what real life TV looks like again. Looking pretty good now. The speckling in the picture is due to my crummy adapter. I keep going through these things, man. I need to get a whole bunch more of them. Cheap Chinese made 300 to 75 ohm adapters. Just not very good. Picture's nice and sharp. No real need to tweak the focus pot or anything. The camera really doesn't show the good colors of this set. You can try and tweak with the AFC, but that doesn't really make it any better. I think with a new adapter this would look sweet. Amazing, huh? We were chasing our tail on that black of blue when it was just a plain old Badard CRT.
Following a developing story out of downtown San Diego, San Diego police have arrested a woman in her 50s for firing shots near the Rock and Roll Marathon. The incident was
Nice.
just before 11 this morning at C Street between 2nd and 3rd Avenues near the finish line for the half and full
What the hell is
marathons,
wrong with
where
people?
27,000 people gathered. The race had to be stopped and more than 4,500 runners were moved to a safety area, which affected their run times. San Diego police spoke to reporters about an hour and a half ago.
At about 10:45 hours, a person flagged down a San Diego police sergeant who was working the Rock and Roll Marathon. They're reported to being a victim of a hit and run at
Come on, quit blinking.
Kettner Boulevard. They also pointed to a vehicle leaving the area and identified it as a suspect vehicle.
It's really sad to see this.
The sergeant followed the suspect vehicle to the A Street entrance to the city parkade. The suspect vehicle, a white Honda.
Everybody's looking for their moment of fame these days. Shame it had to be this way.
The sergeant walked up to the driver's side.
Let's see what else is on.
And the suspect
routed at the Rock and Roll Marathon after police
now it's going to be all over the news.
Pursue an armed woman.
There you go. There's some appropriate vintage TV for you.
Ready for a broad
Well, anyway, on that note, she's fixed, all tuned up, and so now I'm definitely going to use this. I really wanted one of these sets, and now that the blue gun's working, it's a pretty good picture, despite the little snowflakes from the poor adapter. But anyway, hopefully this was a good video for you to watch. In addition to all the setup adjustments, you kind of got to see what real troubleshooting is. So I'm glad you enjoyed the video. More stuff to come soon.